All right, our final type of conic section that we will deal with is a hyperbola. In a hyperbola, they are similar to all the other ones we've covered so far in that they have a center, which in this case we're going to have our center be at 0, 0 for right now. There are vertices, and depending on where the vertices are at, if they are up and down, or sometimes they can be side to side. There are also, I don't know, we don't really want to call them this, but they're kind of like covertices, like an ellipse, but they're not. But they still have the same kind of effect on the hyperbola. The covertices wouldn't be on the opposite axis and so sometimes they can be further apart away, or sometimes they're closer together. Whereas like in an ellipse, the vertices are always the furthest ones away and the covertices are the closest. While in a hyperbola, that doesn't apply. That's why I don't really like calling them covertices, but I don't really have another name for them. So the vertices are on one of the axes, the other ones are on the other axis, and it doesn't matter which ones are closer or further apart. And there's also a focus point, except there are two of them, and those are on the same axis as the vertices. The focus points are outside of where all of the other points are. So these are the focus points. And the only other ones you really have to plot on your graph are the vertices. So what a hyperbola looks like is it's like this, and it is this. And then on this one here, it would be something like that and like that. They're not quite parabolas, but they're similar. It's one on each side. Now, the way that you can figure out what the shape of them would be is that's what these points are for here, is if you would turn this into a rectangle, and then you connect the corners as a line, and you continue that line forever, which my drawing is not very good then, goes like that, and goes like that. These lines are called asymptotes. And let's see, and those help define where the hyperbola goes. So it would be more like this and like that, and then this one would come like so, and then it runs along there, and it runs along there. Because an asymptote is a line that a graph approaches but never intersects. And so like with this one here, if you make that box, you have that line, and you have that line. So this one I did somewhat okay at the initial part, but it should be curved and go there and there. So there's a better picture of what the hyperbola looks like. Okay, well, so now we have to figure out what does the equation look like. Well, there are two of them. One of the equations is x squared over a squared minus y squared over b squared equals 1. And the other one would be y squared over a squared minus x squared over b squared equals 1. Very similar to an ellipse, except it's a subtraction sign underneath. Now, which is which? Well, x squared over a squared and y squared over a squared. So this one, because it's x squared first, it's a left and right hyperbola, whereas when y squared is first, it's an up and down hyperbola. And I shouldn't say if it's first. Excuse me. It's the positive one that is the more important one as far as figuring out which is which. Since the x squared over a squared is the positive part, this one is the negative. It is the left and right. And here the y squared over a squared is positive, whereas the x squared is negative. So therefore this is the up and down one. So with these things then, the vertices, the value of a from center. So they are going to be either, well, depending on which one you're dealing with. In this case, vertices are going to be a0 plus and minus a0, whereas in this case they are going to be at 0 comma plus and minus a. Now how do you know which one is a? Well, it's the bigger number, but you have to understand this could be 64 and this could be 100 here. Well, that's still a because it's a positive 64, whereas you attach that to that one, it becomes a negative 100. So therefore, this is bigger. The positive number is bigger than the negative. Same here. I mean, this could be 64 and that could be 16. Well, now this one's still bigger because that's plus 64 and that's a negative 16. Now, when you were in an ellipse, when you had a plus sign, well, now you just looked at it, which one's the bigger value? Well, here you have to attach the sign with that to figure out which is a. Then these co-vertice points, like I said, you really don't need them other than to figure out the shape and everything, and don't have to plot them, but you do have to figure it out. It's the value of b from the center. And these 2 points are key to dealing with the asymptotes. Because the asymptotes are lines. And if you want to find the slopes of the lines, remember slope is the change in y over the change in x. Well, in this case, you would then put the value plus and minus because you have both a positive slope and a negative slope. That's a positive slope and a negative slope, and here's a positive slope and a negative slope. Well, and you're going by off of these points here, corners of this rectangular box, and the value here is a and the value there is b, so therefore the slope is b over a, and then over here it's the same thing except the slope is a over b's. So you either have to have plus and minus b over a or plus and minus a over b. Well, which do you put over which? Well, it depends on the hyperbola. If you have an up and down one, the y value, it's always the y part over the x part. So in this case, it's a over b, whereas in this case, it is b over a. Just understand it's the y part over the x part of the a and b things. And then the focus points. The foci are same as they are C from the center. And They're on the same axis as the vertices. And to find the focus, or to find the value of C, it's the same thing as with an ellipse. C squared equals A squared, except here it is plus B squared, not minus. It is the Pythagorean theorem. So in order to find C, you have to take A squared and B squared, and then take the square root of it. And those are all the things you need to know about a hyperbola. So let's look at an example. There we have our two equations again. So here we have x squared over 16 minus y squared over 36. So the first thing we know is the value of A is equal to 4. Because it's that. The positive one is A. The value of B is equal to 6. Because the square root of 36 is 6. And the value of C is equal to, so our equation is C squared equals A squared, which is 16 plus 36. So that is 52. The square root of 52 then is the value of C. And the square root of 52 can't be simplified, but understand that it is approximately 7 point something. So square root of 52 we'll put. So just to start with, we know the center is 0, 0. A is 4, and it is underneath x, so therefore it is 4 to the right and 4 to the left. The value of B is 6. 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Those are where B is at. And the value of C is like 7. So that means we're 4, 5, 6, 7. There's our focus. And there's our focus. Now that we want to know how to draw the parabola or the hyperbola, we'll make ourselves a rectangular box from there to there. And then these are the lines. Shouldn't really draw these in like fully, just lightly sketch those things in. And so now our hyperbola does this. And the slopes of the hyperbolas are plus and minus. And in this case, it is going to be b over a because we have to take the y part over the x part. So it's going to be plus and minus 6 over 4, which is the same as plus and minus 3 over 2. That's what the equations of this line and that line would be. Plus and minus 3 over 2x. All right. Looking at our next example, we have vertices at 0, 5, and slopes at y equals plus and minus 5 over 2x. So let's look at our graph. 0, 5. So there. And there. So we know it's a hyperbola that's going like this. And we know the slopes are 5 halves. So up 5 over 2, down 5 over 2, over 2, over 2. So there's our asymptote. There's our asymptote. So since the vertices are 0, 5, that means A has to be 5. And B, because this is 5 over 2, that means that has to be 2. Now, do we need the value of C? No. So if we're going to write our equation, we know that it's an up and down hyperbola because the vertices were up and down from the axis. So that means it's y squared first and x squared second. And that would be 25. And that would be 4. Now, if it asks to find the focus points, the focus points would be the square root of 29 from the center. So 0, comma, plus and minus the square root of 29. And our next example here, we have vertices at 0, plus and minus 3, and focus points at 0, plus and minus 8. So 0, 3. And the focus points at 0, 8. Okay, so, well, first thing we know for sure is because the vertices are up and down and the focus are up and down, it has to be y squared minus x squared. And the distance from here to there is 3. So that means the value of a is 3, which means this is 9. The focus points are 8 away, so that means the value of c is 8. We have to figure out what b is in order for us to finish our equation and to be able to draw a picture of it. So because we have an 8 here and a 3 there, we need to find b. So 8 squared is equal to b squared plus 3 squared. Solving this, 64 minus 9, which is square root of 55, is b squared. So b is the square root of 55. And so this number here would be 55. And the square root of 55 is approximately 7, 8. And this is 7 point something again. So that means if you go 7 point something this way, 3, 4, 5, 6, 7, and a more. And now you draw this box. Those are our lines for our asymptotes. And then our hyperbola does this. And the slopes of the asymptotes would be m equals plus and minus. It's got to be the y part over the x part, so it would be 3 over the square root of 55. Finally, we have this y equals plus and minus 2/3. And we're supposed to write the equation. Well, if it's 2/3, that's up 2 and over 3. So we've got that line and up 2 and over 3. And we got that line. So that means the value of a is equal to 2 and the value of b is equal to 3. Or they're in that ratio. So then you would have to know more information in order to figure out you'd have to know one other thing at least, because it could be a parabola that or a hyperbola that does this, or it could be a hyperbola that does that. Okay, so then let's say it's the red one. Well, then it would be up and down, so the 2 would be part of, this would be 4 here and 9 here, and so it would be y squared minus x squared. And if it's the green one, then it's the other way around. X squared over 9 minus y squared over 4 equals 1. Now, if you did know more, this could say that, let's say this here is 1, 2, 3, 4 up, 1, 2, 3, 4 down, and those are the vertices. Well, so if it's supposed to be up and down 4, then you would have to make this 4 by multiplying it by 2, and you'd then have to multiply that by 2 to get 6. And so then this would become 16, and that would become 36. And now they're in the same ratio. All right. And so now you can do the next assignment on that worksheet.